Hello everyone. In this video, we are going to apply the Ceva theorem, the angle version of the Ceva theorem, to solve this problem from the 1994 China Shanghai Math competition. So, the question is about in a triangle ABC. Angle ABC is equal to angle ACB and equal to 40 degrees. Point P and Q are inside the triangle such that angle PAB is equal to angle QAC is equal to 20 degrees and angle PCB is equal to angle QCA is equal to 10 degrees. So then there's no diagram for this problem, and this problem is asking about whether BPQ are collinear, and we need to give a proof. So this problem should be done without calculator, and please have a try to solve this problem, and we will look at the solution a second later. There are two main results from the Ceva theorem, and the first one is more famous. It's about the ratio of the side lengths, and we can start from A and then go clockwise, and then we can write down the ratio A over B here, and then C over D here, and then E over F here. And the product of these three ratios is equal to 1. So this is the first result of the Ceva theorem. And we have another result which is about the angle. So starting from like angle P, then we can apply the sine P over sine Q in this direction, and then sine R over sine X in this direction, and then finally sine T over sine U. As long as you are counting from clockwise or anti-clockwise direction, the result is the same. So I prepare a diagram for this question, and I labeled all the given angles. And we can also quickly deduce that angle PAQ is equal to 60 degrees. So first of all, we'll focus on the line AP, CP, and we will join BP in the next diagram. So I simplify the diagram, leaving only the three lines AP, CP, and BP. And we let these two angles be A and B. And we'll apply the Ceva theorem. So we start from 80 degrees. So sine 80 degrees over sine 30 degrees multiplied by sine 10 degrees over sine B multiplied by sine A over sine 20 degrees. So now we would like to simplify this expression. Notice that there are two unknowns, sine A and sine B, in this equation. And the remaining are sine 80, sine 10, sine 30, and sine 20. And we don't have any calculator. Oh, sorry. So now what do we do? Okay, sine 30 is half, right? So I change it into half and then multiply it in the numerator. And I noticed that sine 80 and sine 10, there are some relation between them. So we can write sine to sine 80 degrees, and then for sine 10 degrees, we can change it into sine 90 minus 80 degrees. So that is equal to cosine 80 degrees. So then we multiply by sine A, and then in the denominator we have sine B and sine 20, which is equal to 1. So I also noticed that this expression is very similar to the double angle formula for sine. So we know that sine 2 theta is equal to 2 sine theta cosine theta. So we can write it in sine 160 degree multiplied by sine A over sine 20 times sine B, and it's equal to 1. And further notice that these two angles are related. We have another identity, sine 180 degree minus theta, which is equal to sine theta. So we can reduce the top sine ratio angle and then write it as sine 20 over sine 20, and then sine A over sine B, which is equal to 1. So they cancel out to become 1. So we have sine A equals sine B, and A will be equal to B. So we know that the line BP will be the angle bisector of angle ABC. So I focus on other lines which are containing AQ, BQ, and CQ, and we will apply the Seinfeld theorem again. So we start from 20. So sine 20 over sine 10 multiplied by sine 30 over sine n multiplied by sine m over sine 80, which is equal to 1. Well, notice that this expression is exactly the same as the previous one, so we can quickly deduce that m is equal to n. So now we know that m is equal to n, and P and Q, they both lie on the angle bisector of angle ABC. So we know that B, P, Q are collinear. And I hope you guys will like this video, and we will see you in the next video. Thank you. Bye bye.